Hello. Today we will be going through what we learned in ME 435 Lab by walking through our process and the final result of our final project. But before we do that, we must first explain the key skills we gained from each of the previous labs that contributed to the final lab. Starting with Lab 1.
In Lab 1, we started learning the basic commands in the Dobot Vision Studio software. We started with the three basic move types: joint, linear, and jump. We were also introduced to the hardware parts of the Dobot and practiced swapping out and using different end effectors like the suction cup and the gripper. We also learned the use of IR sensors and how to retrieve and use the signal from them within the software. We also used the computer vision to start recognizing patterns and decode 2D QR codes. For the final task in Lab 1, we combined everything we had learned, including basic robot motion, end effector control, conveyor belt operation, I/O communication, and QR code recognition to create a continuous program that could run entirely on its own. The goal was to design a workflow that allowed the Dobot to perform a repeated, automated routine when run continuously was selected.
Now, transitioning to Lab 2. We focused on the camera, like saving a live image into a file and opening it as an image file. We also learned how to create an image template so that it can detect the same object in a certain radius. Next is measuring the distance and angle of two objects in the same image by assigning points on each of them. We also learned the most important thing, which is the calibration point that is crucial for converting the image coordinate to an actual tool coordinate. For the final task, we learned how to make the robot identify one color and picking all of the same color blocks from a bunch of different color blocks. Now, the final lab, Lab 3, was used to match each rectangle with its corresponding slot and calculate the orientation angles of both the rectangle and the slot. Once we obtained these angles through feature matching and script functions, we could rotate the rectangle to the correct orientation. After converting the image coordinates to physical coordinates, the robot was able to place each rectangle accurately into its matching slot. Through this lab, we learned the fundamentals of robot control and communication protocols, including how to coordinate actions between multiple Dobots. We also learned basic image processing tools and used them to build a functional, vision-guided, automated system.
For our project, we decided to make the two robots play a game of tic-tac-toe. To achieve our project objectives, we first made a hierarchy of tasks that were to be completed by the two robots. First, the first robot would scan a grid of tic-tac-toe and choose a block to cross off using its camera and fast matching to a template created by the team. It would recognize one of these 9 boards and mark the camera image coordinates of the center. Then, using a calibration file, the robot would convert these image coordinates to physical coordinates for the robot arm to move to. The robot then uses a move point command to reach the center of the chosen square. After this, the team added a shell module to code in some movements that the robot would do within the chosen square. We used the world points from the calibration file as inputs and added different values each to the x and y and use the result as an output. This output would, when used in the following move point blocks, cause the robot to create diagonal lines starting from the center of the square. Lastly, the first robot moves out of the way and sends a signal to the second robot. The second robot uses a branch after the receiving code, which causes the robot to wait for a signal and proceed only when prompted to by the first robot. Thereafter, the second robot carries out the same procedure to choose a new square on the board. During this, the first robot waits for its turn using a wait time block.
During our final project, we had to make a few changes and iterations to our Vision Studio code in order to perfect the actions. Some of these iterations were as follows. First, we tweaked the delay time for the first Dobot to wait for a longer time period. This is so it would not interfere with the second Dobot's actions. Secondly, we were observing that the marks made by the Dobots were not enough for the fast match to recognize the already used blocks on the board. To solve this problem, we came up with multiple solutions. We added symbols in the center of the blocks for the fast match templates to have more information to look for. This would allow the marks to ruin the symbols for the fast match to reject each used square. We also added more movements to the Doughbots within one square to properly cross off the symbols until they were not recognizable. We also changed out the end tools from pens to markers for a more significant mark. And lastly, we increased the match score criteria for each template. We also fine-tuned the compressibility and threshold.
In the end, we were able to carry out a game of tic-tac-toe. The first Doughbot is able to recognize the board and choose one of the squares as its first move. The Doughbot proceeds to locate the square it has chosen and cross the center mark with its marker as the end tool. Then the Doughbot sends a signal to the second Doughbot through the circuit, and the second Doughbot, having received the signal, scans the board and chooses its own square as its move. Similar to the first Doughbot, it proceeds to locate the mark on the board and cross it off with the marker. Then the first Doughbot repeats the process.